More than 900,000 people live on the island of Oahu, which has a peculiar shape. Although deeply carved by erosion from water and wind, the southern half of the extinct Ku'u'ula'u volcano, which comprises the northeastern half of the island, including the area which has the famous Diamond Head tuff cone, generally has a gentle slope typical of a shield volcano. In contrast, its northern half contains a rather steep incline, including a singular interconnected massive cliff face, which in some sections towers more than 2,500 feet above the lower terrain to the north. This cliff formed due to an ancient catastrophe which formed more than 1 million years ago that split the island in two. Looking to the northeast of Oahu, you can see remnants of this disaster. There, on the seafloor, are remnants of one of the largest known landslides to ever occur, being more than 1,000 times more voluminous in terms of landslide volume than the 1980 flank collapse of Mount St. Helens. This ancient landslide is known as the Nu'uanu Slide and caused around half of Oahu's Ku'u'ula'u volcano to collapse into the ocean in a single event, with pieces of the volcano traveling up to 149 miles or 240 kilometers distant. The landslide had an estimated volume of 720 cubic miles or 3,000 cubic kilometers of material and created a destructive Pacific-wide megatsunami with wave heights likely surpassing 500 feet in height in some locations. Additionally, this collapse deposited some marine blocks on the ocean floor, which, per a direct quote from a U.S. Geological Survey webpage, the largest of these blocks is about the same size as Manhattan Island. This destructive event created the modern cliffs and shape of northeastern Oahu, as by making two diagrams, aka a before and after, based off of current Google Earth imagery, the island before the Nu'uanu slide likely looks something like this. And, after the slide, the island instead somewhat resembled its modern appearance, looking like this. So, what triggered this catastrophic event? To answer this question, we must first understand the geologic history of the island of Oahu as a whole. The modern island of Oahu was constructed via eruptions from two large and now extinct shield volcanoes which formed due to the underlying Hawaiian hotspot in the mantle. The Waianae volcano formed the southwestern half of Oahu, while the Ku'u'ula'u volcano constructed the northeastern half of the island. The Waianae volcano began forming first approximately 3.8 million years ago when a large amount of lava erupted onto the ocean floor. Over a duration of approximately 100,000 years, numerous submarine eruptions built this volcano until it reached the ocean's surface. This shield volcano eventually developed into a complex with a curved rift zone during the next 1.6 million years. Beginning around 2.6 million years ago, the Ku'u'ula'u volcano erupted, forming a shield volcano edifice which likely looks somewhat like, albeit smaller than Mauna Loa, with a central caldera and rift zones dotted with lava flows to the southeast and northwest of this caldera. Due to the nature of the Ku'u'ula'u volcano, its existing caldera at the time was slightly off-center from the middle of the volcano's edifice. As a result, over hundreds of thousands of years, the northeastern flank of the volcano became overloaded with volcanic rock, causing it to slowly slide to the northeast at perhaps a rate of a few inches a year. Then, 1.25 million years ago, with a margin of error of plus or minus 250,000 years, a large section of Ku'u'ula'u's submarine flank below sea level began a very large landslide. Soon, this propagated to include the volcano's edifice above sea level until almost half of the entire volcano was sliding into the ocean. After the slide ended, the shape of Oahu was forever changed. The remnants of Ku'u'ula'u's original caldera can now be found in Kaneohe Bay. Thanks for watching. If you would like to request a specific topic, please leave a comment below. Additionally, I would like to thank Roger.Lee for becoming a new channel member on YouTube of Geology Hub.